Let's plot that graph based on the data that we have there. I have this plot here. It's a position versus time graph. And then here, this time, I have assumed that every T1 and T2 has an equal interval. In that case, we may consider it as this is 1 minute, 2 minutes, 3 minutes, and so on. Here also, could also define it as, but this is not the correct scaling, no? Imposible po kay, in a minute, nag-travel na siya 1 meter. That's not, it doesn't make sense. So we could assume that this is the first 50 meters. After 2 minutes, the person has traveled 150 minutes. Okay, so on and so forth. But my point here is just want to illustrate to you the graph. This is for xt1, xt2, xt3, and so on. Notice also that I have identified 0 for the purpose of using this graph. Now, if we want to go back, if that's the case, if this is 0, then looking back at our graph of our path here, we could now identify our 0. Our 0 must be somewhere here, and that's our 0 position. We could call that as our reference point. Time 1, this is xt sub 1. At time 2, this is xt sub 2. It's located here. Okay, this is actually the location of xt sub 1. This is your xt sub 2. This is your xt sub 3. This is your xt sub 4. And of course, going back is of your xt sub 5. Of course, 1, maura man na siya, T1, T2, T3, T4, T5. So kung ato na siyang i-plot, ang graph, it would look like this. So I'm just tracing the points. Maybe there's some story here. Basically, that's the plot of the position time graph of that person walking down F Torrey Street. By definition, velocity, we know that average velocity, emphasis on the word average, that's bar. Average is just delta x, delta t. If we are going to connect a line, there, okay. Then let's just put some emphasis on the line para klaro. Then let's put a color para klaro po sa inyong end. Let's have color blue. Okay. So that's the line. That line there is connecting kanang duha ka points, T2 x T2 and T3 x T3. In our graph, this is our delta x. This is the change of x. Wait, let me draw. So delta x, this is the amount of change in x, and this is, of course, our amount of change of time. By definition of velocity, change in x and change in time, that is actually just the slope, emphasis, slope. This is just the slope of that line, this line. So if you have a straight line from that point to that point, then you could get the slope, that's rise over run, di ba no? So that is basically just your slope. Using a position time graph, then you could have that velocity there is just xt3 minus xt2 all over t2 minus, t3 minus t2. So that's a slope. So the slope of a line in a position time graph is actually the average velocity. On the other hand, let's recall our definition of average speed. And we use the symbol V. Note that we define average speed before as total distance traveled by any moving object divided by the time it takes for that distance to be covered or traveled. If your concern is here, what is the total distance traveled by that person? Of course, this is the total distance traveled by that person. Here, from here, at xt1, it moves to xt3, and then it goes back to xt5, which is equal to xt1. So the total distance traveled is just you have to add this. What is this? Position here, it's just xt3 minus xt1. Then, it's the same lang man ang length, no? So the total distance traveled by that person, you just multiply it by 2. And that's the total distance. The average speed for the entirety of the motion of that person we are talking about, it's just equal to times 2 of xt3 minus xt1 divided by t5 minus t1. So that's the average speed of the person. Whereas the average velocity of the person from xt1 moving back to xt1 for within, let's say, time interval, let's say if we use the unit as minutes, for 5 minutes, the average velocity is 0 because displacement is 0. Wala man siya na-displace. Nibalik naman siya kung asa siya nag-start, right? Wala siya nag-displace from its origin. That's for velocity. I hope you could distinguish, again, the difference between velocity and average speed. As you can see here, that's for T2 and T3. Now, let's consider within 4 and 5. The average velocity in 4 and 5, we expect that it is going to be negative. Average velocity from T4 and T5, that is the position at T5 minus the position at T4 over T5 minus T4. In that case, it's a slope. The same thing here. If you notice, if we try to connect a line from T4 and T5, that's the line there. What do you think is its slope? Is it positive, negative, or 0? This line here, let's change the color. Negative, right? Therefore, we are expecting that this is a negative average velocity. Now, how about the velocity of the person on this particular time? There, at time t3. At time t3, that's the line here. Okay, this line. What do you think is the velocity of the person at exactly t3? Is it a positive velocity? Is it a negative velocity? Or 0? By looking at the slope of that line, okay, it's 0. Obviously, it's a flat line, so there's no rise. Diba? This is the rise, this is the run. It has run, of course, but no rise. Rise pa nga. If it's a flat line, it's a line along horizontal axis, then the slope with respect to horizontal axis or x-axis is 0. At time t3, exactly at time t3, the slope is 0. Now I'm introducing the term at that particular instant. The term is instant. So let me introduce to you the concept of instantaneous velocity because that's what we are actually looking at a moving object. Every time we observe an object that is moving, what we are looking at is either instantaneous speed or the instantaneous velocity. That's most of the time we are concerned of. Okay, so instantaneous velocity is like this. Instantaneous velocity, v sub t, at any given time. Kanina, I showed you the velocity at t3, exactly t3. How about at exactly t2? What is its velocity at t2? Again, we could just simply plot a line that is passing through t2 because once we have a line, then we could calculate the slope, if you could calculate the slope. This is our line at t2. Okay, it's passing t2 once. And that the slope of that line indicates the velocity. And of course, it's positive because that's the orientation of our line. It's positive velocity. And once you know the slope of that line, then you know the velocity. However, it's quite challenging because how would you know the slope, right? Pwede man, sir, I need to know this point, and once I know this point, then I could determine the slope. Another approach is we could make dt to be very, very small. Let's make the observation very small. Kaya nga, when we look at things that are moving, di ba dali raman ta kayo magtanaw, and then our brain automatically estimates, or if our speedometer indicates exactly at that particular time, indicates the instantaneous velocity, or for magnitude, the instantaneous speed. If we could make delta t to be very tiny, there, just small amount of delta t, we could calculate for the velocity. Okay, because as you could see, the position is affected by the time. In fact, position is a function of time. However, we don't know the exact function yet. So in that case, if we could make delta t to be very, very small, so we could have a limiting case. If you can still remember your limits in your pre-cal, we could define instantaneous velocity to be the limiting case of the position at time t plus a very small amount of time. Nya, minus tanday nimo og initial time ganina divided by a small amount of time nga imong gi-adjust. Again, defining that delta t is very small. In that case, delta t approaches zero. Not zero, but approaching zero. So in this case, this is the first order of derivative. This is equal to dx over dt. So instantaneous velocity is dx dt. Now, I want you to remember this equation because we will be using this for the entire general physics. Do not forget this important equation. Dx over dt is velocity at any given time. I want to emphasize also this quite a very intriguing. Uh, it's quite confusing actually. These two expressions here, plus for velocity and for instantaneous velocity and instantaneous speed. As you could see, in instantaneous speed, it will always look at the magnitude only, and it doesn't care of the sign. Here, for example, you have this two measurement. Again, we just simply use plus and minus to indicate direction, meters per second. Now, if you could see, let's label this as, this is our, let's call this as VA, velocity A, and this is VB, velocity B. And it is, in terms of speed, VB is greater than VA, as you can see that, in terms of speed. However, in terms of velocity, VA is greater than VB. Why? Positive numbers are greater than negative numbers. So I hope that's clear.